All right, so I'm going to go over the uh, answers, how to do each of the 2 through 16 even on this worksheet. All right, now these are, even though we just did du over u, does not mean every single one of these or every single one on your quiz coming up next week is going to be du over u. All right, it just gives us another thing to be able to use with substitution. So for non-trig problems, what we can make u is anytime we have some quantity raised to some power, you can make u whatever's on the inside. If we have something that is underneath a radical, big thing, we can make that. All right. And we also now have, if we have a fraction, you can make u whatever is in the denominator. Okay. If we have a trig problem, if it's just one trig problem, you make u whatever comes right after it. If you have multiple, if I would have multiple trig functions and different powers, right? A situation like this, you would make u secant 8x because you picked the one with the highest. Or it could be that you might be using something that is in the denominator, just like you would for this, okay? If none of those, if it's just listing a bunch of separate things, you might just take the integral of each individual thing. That's the first thing that we did, okay? So looking at number 2 here, that's because we go ahead and do the evens, all right? Feel free to try the rest. Doesn't mean you can't do them. It's just I didn't want to have to give you guys so much work. All right. So we have two trig functions. They have different powers. The one that's higher is tangent 2x. So we include all of the trig and what comes after it when you have two trig functions with different powers. All right. So my u is going to be tangent 2x. All right. Then I take the derivative of that. Remember, you are allowed to use your formula sheet. The derivative of tangent is secant squared. So take the derivative of the outside, which is secant squared 2x, times the derivative of the inside, which is 2. I'm going to throw a dx out there at the end. All right. Remember, all of du needs to be in here. All right. So I have secant squared 2x dx. I need a 2. All right, which means I put a 1/2 on the outside of my integral. This here in the pink box is my du. And then I'm left with tangent 2x. This is u to the 5th. All right, so this is not a du over u. It's just normal trig one that you guys have done before. Now we just integrate it. It's 1/2 u to the 6th over 6 plus c, which u to the 6th is tangent 2x to the 6th power over 12 plus c. All right, and there is your answer for number 2. All right. All right, number number 4. Okay, so 4, we have two trig functions. We have secant 9x, we have tangent 9x. Technically, this 2 is bigger, yes. But the thing is, we have a fraction. So if you see this situation like this, and just show you what happens, it's most likely going to be u is going to be down here. But if you go by what we did before, and if I made u secant 9x, then I would get secant x tangent x. That's nothing good's going to go here. All right, so we're not going to be able to do it. So that's fine. You're like, okay, well, it can't be secant 9x, which means I then have to do the bottom. I'm going to do the denominator. All right, remember we have that as an option as well. So my u is going to be tangent 9x. The derivative of tangent, remember you can look at your formula sheet, is secant squared, which we just did up in the previous one. Keep the inside the same, times 9dx. Okay. So secant squared 9x dx, I am just missing a 9. So I add in that 9. I put a 1/9 on the outside. This whole top is du. All right. All of that is du over tangent 9x, which is my u. So this is a situation we have our du over u. If you forget what the integral of du over u is, it's on the right-hand side up top on the formula sheet, and it is remember, just keep the 1/9 out there. It is the natural log of the absolute value of u, which in this case is tangent 9x plus c. So there's our answer. 1/9 natural log, absolute value, tangent 9x plus c. All right. All right, 6. We do not have a quantity being raised to some power. I don't have anything underneath the radical. I don't have trig. I don't have a fraction. I mean, this is a fraction, but not the whole thing. This is just take the integral of this one, this one, this one, this one. This is like one of the first ones we've been on the first day of that we did this. All right, so integrate 3x to the 6th. That is 3x to the 7th over 7 minus 1/4 x to the 5th over 5 minus 7x squared over 2 plus 9x plus c. And the only other thing that we need to do is simplify that. So I'll just rewrite this all out. 3x to the 7th over 7 minus x to the 5th over, what is that, 20 minus 7x squared over 2 plus 9x plus c. There we go. All right, so this did not have to use substitution for. All right, and you'll get your review Monday. All right, and I will, probably Tuesday, probably put out something where, make sure there's gonna be this many of this question. Make sure you know how to do what particular examples, the kind of the breakdown like I normally would in class. All right. All right, so that's 6. All right, 8. We're back to another. All right, we're back to another trig one. All right, now we have secant, we have tangent, but they are the same function. All right, so what we're going to do is, same power. All right, so we just u is whatever comes after them. All right, so it's going to be 6x. The derivative of 6x is 6dx. I add a 6, so there's my du, right? So I get 1/6 integral of secant u tangent u du. All right, so this is where you got to be like, all right, well, what's the integral? What's the integral of secant u tangent u? If you don't know, where are you going to look? You're going to look at your formula sheet. All right. Remember, if you don't just look there, all right. Thought I brought it up here. Yeah, there it is. Okay. So you go, the integral's always on the right side. You look, oh, there's secant u tangent u. Oh, that's secant u plus c. All right. So that means what you do is you then go and keep the 1/6 out there. It says all of this was secant u plus c, but u is just 6x. So it's secant 6x plus c. All right, use the formula sheet. It is there to help you. All right. All right, 10. All right, 10, we've seen this type of example many times before. I feel like this is the kind where you split, right? I got to rewrite this, got to rewrite that. All right. And when I do that, all right, I get, now you might think, oh, I could use 5x to the 4th. It's not really going to work out if I use the bottom. You want to split this up. All right, so this is the integral of 1 over x plus x over, that's 1 over x to the 4th. Okay. Now, issue that comes, so we're going to do each of these separately. All right. All right, and you'll see the issue with this one is we have x. We've never done with just x before now, because if you have x to the negative first and I integrate that, I get x to the 0, excuse me, over 0. So I can't do it that way. But for this particular one, if I made u x and I made du is 1 dx, this becomes integral of du over u. All right, so this part right here is the natural log of our u, which is x. And then I do this one, which is x to the 4th, which is x to the negative 4th, which is x to the negative 5th over negative 5. So it's minus 1 over 5x to the 5th plus c. All right. So this just happened. We've done one where you had a split like this, but it just so happens this one becomes du over u. So if you have the integral of 1 over x, that is always just the natural log of x. All right. That's because what's the derivative of natural log of x? 1 over x. All right. So there is your answer. And then we do this one just like we normally would, just a basic integration. All right. Let's see. 12. All right. 12. Back to how we originally started. We have a quantity being raised to a power. All right, quantity being raised to a power. So you pick what u as whatever is being raised to the power. So we got 3x plus 1. The derivative of 3x plus 1 is 3 dx. All right. I have a dx. I'm missing a 3. So that is my du, which I'm good with. So I had a 1/3 on the outside. This is my u, right? So it's u to the 6 du, which is 1/3 u to the 7th over 7 plus c. So my final answer is 3x plus 1 to the 7th power over 21 plus c. All right. All right. Sorry, I got things falling over my desk here. All right, 14. All right. So with 14, I don't have a quantity raised to a power, I don't have a radical, but I do have a fraction. So let's make let's try u as whatever is in the denominator. So 1 minus 4x. The derivative of 1 minus 4x is negative 4 dx. Okay, now this 5 has nothing to do with negative 4. Let's move that to the outside. So that means this 5 is now on the outside. All right, so that means it's gone from here. All right, I have a dx, so I need a negative 4 there because that's my du. So if I put a negative 4 there, I move the reciprocal of that to the outside, so it's a negative 1/4. But there's already a 5 out there. Remember, you can move any constant on the outside. So that's going to become negative 5/4. Integral negative 4 dx is just my du. This is just my 1 minus 4x is my u. So I'm left with du over u. So negative 5/4 du over u. If you forget what that is, the integral of du over u is natural log of u plus c. Natural log of u, which was 1 minus 4x plus c. All right, so the negative 5/4 is probably what confuses people the most. Is this 5? Any constant you can move to the outside, so that's just 5. You don't take the reciprocal of it because you didn't add it in there. It was already here to begin with, so you just move to the outside. You had to put a negative 4 in there to make this equal to du. To balance that out, that's why I had the reciprocal of negative 1/4. All right, and then negative 1/4 times 5, that's where I get the negative 5/4 from. Okay. All right, last one, right? You only had to do up to 16. All right, so here we have a trig one. So we have, pretty much it should be obvious what u should be. Because if we only have one trig function, we always make u what comes after this. Plus we have that's what's in the denominator, which is the other thing we could possibly pick. So it's got to be, u's got to be the square root of x. Which remember, square root of x is x to the 1/2. The derivative of this, some of you probably could just tell me what it is because you've memorized it, because we've done it enough. But you get 1/2 x to the negative 1/2, which is 1 over 2x to the 1/2, which is just 1 over 2 root x. All right. So the derivative of the square root of x is always 1 over 2 root x. So I have the square root of x here. I have dx, right? What am I missing? Well, I'm missing a 1/2. All right. I'm missing the 1/2 to get my du. Since 1/2, I added 1/2 here, which means I put the reciprocal of that, which is 2. All right. So all of that becomes, it's circled as my du. I get cosine u, whoops, that's an awful u, du. If you forget what the integral of cosine is, not a big deal. You should know that, but it's sine u plus c. All right. So it's just 2 sine u, which is the square root of x, plus C. All right. So that's all that you guys had to do on this worksheet. Looking at this worksheet, don't worry about really these crazy subtractions. They're not going to be on there. All right. These other ones that the odds you should know how to do. All right. And that's something that you could be asked. There's going to be a lot more practice of the integrals on the review. All right. You're going to get the review sheet Monday. I'm actually going to give you 2 days to work on it. And then your quiz, depending on which class you are in, class 7, yours will be on Wednesday. And 1 and 5, yours will be on Thursday. Okay. If you guys have any questions, please let me know. If you want to have some extra help and want a Zoom session or something like that, let me know and I'll set one up. Okay. Hope you guys are all hanging in there, and let me know if there's anything I do to help you out. All right. Have a good one.